Okay, so let's talk about dividing complex numbers. And in order to understand how to divide complex numbers, we have to understand how to divide radicals. So you learned back in Algebra 1, talked about a little bit of geometry, we even talked about it a little bit earlier this year. If you have a square root in the bottom of a fraction, that is not fully simplified because we never want to be dividing by a square root. It's an irrational number. So to fix that, we go through a process called rationalization. You multiply the top and bottom by the square root of whatever was in the bottom. The reason we do that is because on the bottom then, we get the square root of 9. On the top, that's 6 times the square root of 3. And the square root of 9 is something that will simplify. That's why we multiply a square root by itself, so we get something that's a perfect square underneath the square root. Square root of 9 is 3. And remember that numbers that are outside the radical can be divided. So this would end up being 2 square roots of 3. So 6 divided by the square root of 3 is the same as 2 times the square root of 3. You can check that with your calculator. Now, when we're working with complex numbers, remember that I is a square root. So if you see an I in the bottom of a fraction, we're going to have to rationalize it. So we're going to take this top and bottom, and we're going to multiply the top and bottom by the square root. Now in this case, the square root is just I. You could multiply by 3i if you wanted to. You just have to simplify the fraction at the end if you did. So 5 times I on top gives me 5i. On the bottom, we get 3i squared. And remember, I squared is always negative 1. So this would be 5i over negative 3, which I could write as negative 5/3 I. So that's a purely imaginary number. Now, you can also divide numbers that aren't purely imaginary, that are complex. But in order to understand how that works, we need to work with a regular square root example. So up here, I have 2 plus the square root of 3 divided by 5 plus minus 2 root 3. So when people first look at this, they always think, oh, I'm just going to multiply the top and bottom by the square root of 3. Don't write this down, because it's not right. Let me show you why. I have 5 minus 2 root 3, and I'm multiplying it by something, which means when I multiply it on the bottom, I would have to distribute. Now when I distribute the square root of 3 to the 5, I get 5 root 3, and then I get minus 2 root 9. Now this will turn into 6, but this, I still have a square root in the bottom. I didn't get rid of it. So if I tried to multiply by square root of 3 again, this square root of 3 would go away, and then this one would get a square root of 3 back, or we'd be just stuck in an eternal loop. So this is not the way to go. We can't just multiply the top and bottom by the square root of whatever's sitting there. So then typically what people say is, oh, it must be like the other thing, and that we just multiply by what's on the bottom. Well, don't write this down either, because this isn't right either. If I were to multiply these things together on the bottom, that would require foiling. 5 times 5 is 25. 5 times negative 2 root 3 is negative 10 root 3. Negative 2 root 3 times 5 is negative 10 root 3. And then negative 2 root 3 times negative 2 root 3 is positive 4 root 9. Now, this again will become 4 times 3, which is 12, but we have this negative 10 root 3 and negative 10 root 3, which is negative 20 root 3. So we still have a square root on the bottom. However, it's super useful to see this because if one of these happened to be a positive, then these things would go away and I'd be left with just the stuff that simplifies down. So here is where the unlocking of the magic is going to happen. When we want to get rid of a square root in the bottom and we have something that's added or subtracted like we do here, we're going to multiply by what's called the conjugate. And the conjugate is essentially taking that thing that's on the bottom, 5 minus 2 root 3, and changing the middle sign. So if that had started out with a plus in the middle, I would change it to a minus. But it started out as a minus, so I'm going to change it to a plus. Now when I FOIL that out this time, 5 times 5 is 25. 5 times 2 root 3 is 10 root 3. Negative 2 root 3 times 5 is negative 10 root 3. And then negative 2 root 3 times positive 2 root 3 is negative 4 root 9. Now those go away. And then this is minus 12, so I end up with 13 on the bottom, which doesn't have a square root anymore. So to keep the fraction legal, I have to multiply by the same thing on top. And again, that requires foiling. So that would be 2 times 5 is 10. 2 times 2 root 3 is 4 root 3. Root 3 times 5 is 5 root 3. And 2 root 3 times root 3 is 2 root 9. This would be 2 times 3, which is 6. And so then I can combine like terms. 10 plus 6 is 16. 4 root 3 plus 5 root 3 is 9 root 3. And this is the answer. It's a single number. Now, the process is going to work the same when you have complex numbers. I have 4 plus 5i in the bottom. I have a square root in the bottom. I have to get rid of it. I have a plus something on the bottom, which means to get rid of it, I have to multiply by the conjugate. So I'm going to change the middle sign. By the way, that conjugate word is spelled like this. And these two things are conjugates of each other. So I'm going to multiply the top and bottom by that. When I FOIL it on the bottom, it's 16 minus 20i plus 20i minus 25i squared. These go away. And then remember, I squared is negative 1, so this is negative 25 times negative 1, so plus 25. So I get 41 on the bottom. And then on top, I'm going to FOIL it out as well. 20 minus 25i minus 12i plus 15i squared. Remember that I squared is negative 1, so this is negative 15. 20 plus negative 15 is 5, and then minus 37i. Now, this is a single complex number, and I can show that by breaking this fraction up. And now this is in the form a plus bi, where b is a negative number. So to divide to divide imaginary numbers, complex numbers, you essentially either, if they're purely imaginary, just multiply by I on top and bottom. But if they're a mixture, if they're a hybrid, then multiply by the conjugate on top of the denominator on top and bottom, and you'll be good to go.